Okay, let's take a look at Chapter 4, Void Methods. Now we got math methods where you can just, no need to import, just can use with this. So you do math.sqrt and then, for example, 13. That'll find the square root of 13. There's POW. Here's documentation listing all the different methods you can call. You can embed one function in another. So you can do math.log and then pass that into math.exp. That's called composition. Now, specifically, what we're going to be looking at here is adding our own methods. So let's start a new project. File, new project, and I'll call this. Let's see, Java application. I'm gonna call this void methods. Example. Excuse me. Void methods example. Now click finish. I didn't have our GUI elements loaded here, so we'll use this. Refer back to. And I want to expand to source packages. Right click on this package and choose new and choose JFrame form. And you give that a name if you want. I'll just click finish. Make that a little bit bigger. Okay, so we're going to program methods in. And so I'm going to do an example where maybe I'm calculating the compound interest. Okay, so I need a label. And another label there. And third one. Now the first one, if I right click on that, choose edit text, I'm going to program area amount is equal to P times E to the RT power. So I need P, which is principal. I better just say P since I don't know how to spell principal. I think that's right. Okay. Paint.net was finishing installing, so I was gonna wait, but I needed to get this created. So, and then let's see, R is rate, and T is gonna be time. Okay, so I want a text field, wherever that's at. There we go. Another text field. And another text field. I want a button. And label here. And another label for my answer. Okay, I'm going to start naming some items, but I'm going to click up here to unselect. So left mouse click. Now left mouse click and hold down and drag, draws a rectangle around everything, and I want to change the size of everything so I can actually see it. Okay, that's better. So this one, I'm going to right click on it, say change variable name. I'll call this TF underscore principal. Right click on this one, change variable name, TF underscore rate. Right click on this one, change variable name, TF underscore time. Right click on this, change variable name. I'll call this BTN for button. Calculate. Right click on this one. I'll call this change variable name LB underscore amount. Right click on this and edit text. And this is going to return our amount. Right click on this one, edit text. I'll do a backspace, enter. Right click on this one, edit text, backspace, enter. Right click on this one, edit text, backspace, enter. Someday I'll actually learn the pattern why it resizes everything. It's one of those things that's an annoyance, but it's not where it's worthwhile for me to Google it. Right click on this one, edit text, and I'll have it say calculate. And right click on this one, I'll say edit text, and I'll just put 0.00 to begin with. Okay. So that's our setup. And update an index for central repository. Go ahead and save that. Now I want to program the button. So I'm going to right click on the button. Maybe. Okay, right click on the button. And I'll say events, mouse click. Beauty of naming your button is you can easily identify which one to program. Okay, so we're going to be bringing in double, and we'll bring in principal. We'll have rate, we'll have time, and we'll have an amount. So principal is going to equal to double dot parse double TF underscore principal dot get text. I don't know if that needs a toString on it or not, but we'll see. And by the way, I'm just going off of this right here. So if you're working with double, you do double dot parse double. If you're working with integer, then it's either int or integer spelled out dot parse in. Okay. And then rate is going to equal to double dot parse double tf underscore rate dot get text. And time is going to equal to double dot parse double tf underscore time dot get text. And amount is going to equal to principal times, now it's PE to the RT power. So I want to do a math dot EXP is where you're taking the number E and raising it to a power. And RT would be rate times time. And doesn't like something. Okay, now I want to write that back out to my form. TF underscore principal dot set text. And I think this is string dot value of, if I remember right, amount. We'll know soon if it doesn't work. And I'll go ahead and run this. I don't know if I need to disable Avast, but we'll see. Okay, so if I put 3 and 0.04 and 5. Looks like I'm writing it out to the wrong place. So let's fix that. I would set it out to the label. What am I doing putting it back in the TF principal? LB underscore, what I call it. It's over there on the left-hand side, bottom left, amount. There we go. Try number 2. 3.04 and 5. Okay, so we get that. Let's go into Excel. Just double check it. Okay, so equals 3 times e to the 0.04 times 5 power. It gives us 3.664208. Okay, got our code correct. Now, nothing new in what we just did there. That's what we've been doing. What I want to do instead is I want to put this in its own separate method. You see here we have public static void new line. So let's do it there. Now I'm gonna leave that button there, but let me add a new button, and I'll call it calculate. You can actually right click on this and choose copy or duplicate even, I suppose. There you go. And right click on this one, and I'll say edit text, and this will be calculate 2. Okay, so I'm gonna right click on that, and I'm gonna choose events. It still points to the same one. I didn't realize it'd do that. This one doesn't point to. Okay, I think it created its own code. I don't usually use duplicate. Events, mouse, because that's a different name. Calculate 1. But it didn't put any code there. That's interesting. It created the method, but didn't put any code there. Okay, so now here, we want to call another method. Public static void calculate interest. Interest. Okay, so now I'm going to copy this code here. And I'm going to paste it here. Public. Try it again. Public void. Calculate interest. And then down here, I'm going to call calculate interest. Now let's check this, and then I'll come back and explain everything that's going on. Excuse me. .04 and 5, and I click calculate 2, and it works. Okay, so when you click the button, it comes down here, and it says, hey, I need to call calculate interest. And so it knows it's not Java commands. It's a method you created. Notice it has a beginning parentheses and closing parentheses there. When you're calling methods, you have to have those. Later on, we're going to see where you can pass arguments in, which I'm going to show because technically uh, this section is just working with void methods, but that doesn't say you can't pass in parameters. Okay, so notice the form here. Public. I could probably have done private. Private would mean it can be called from within this class, which would be fine. See, like if I change that to private, it would still work. Like that. Now, public means it can be called from outside this class. So at this point in time, it doesn't matter whether you put public or private there. If you think about what that means in terms of your own information, if you got private information, if I ask you what your social security number is, you're probably going to tell me it's none of my business. That's private. If I ask you what your name is, unless you think I'm stalking you, you're probably going to tell me your name. That's public information you share. Same idea here. We have private that we only want to call within that class. So it's information that we don't want people to access directly. In this case, code. Now, void means nothing's returned. It means it calls this and nothing's returned from where it's called, or nothing's returned to where it was called. Now we're going to take a look at where we have methods return items. And then this is whatever name you want to call it. I call it a calculate interest, but you can't start with a number. You can't have spaces in it. Can't have special symbols like dollar signs and items like that. Let me grab a drink here. Then you have to have beginning parentheses and closing parentheses. Have to have a beginning curly brace and a closing curly brace on your code you define for that. Well, what's the benefits of this? Because you're saying, well, I don't see much difference here. That's the exact same code you did before. The benefit of this is we can call this calculate interest from different locations. And I don't have to repeat the code because the code is just in one place. This is the one of the basic principles of code reuse. If, for example, if I come back to the design here, I programmed clicking this button. Let me program just putting my mouse over it. So if I right click on that, and I choose events and mouse, and I think it's mouse entered. Mouse entered is where your mouse is over it. You haven't clicked anything, you just put your mouse on it. Then I can come here and I can program calculate interest. So let's take a look at how that works then. Okay, I got 3, 0.04, and 5. Now I'm going to just put my mouse over calculate 2, but I'm not going to actually click anything. And you see how it went ahead and ran that? You can actually put this behind a lot of different events. If you right click on here and choose events, these are all the different things you can program. Most of these I don't know what they are, so don't worry about that. Mouse wheel moved. Let's program that. And again, I'm gonna have it called calculate interest. And I'll run that. 3, 0.04, and 5. Now, at this point in time, I got my mouse over my window. Probably if I'm over here, it won't work. But I got my mouse over my window. And if I move my mouse wheel, that's interesting. It didn't, I guess I never have programmed the mouse wheel. There it goes. Oh, I did, no, I did it over that. Never mind. Like let's change this to 8. Doing my mouse wheel. It's not doing anything with the mouse wheel as far as I can see. The mouse over there though and recalculates it. But anyway, uh, failure on that part. What I really wanted to show is you could call the same code from multiple places. You could call from 10 places in your code. So then, if this code needs to be changed right here, you change it in one place. You don't have to change it in 10 places. The more copies you have of something, the more you are likely to forget one, to screw it up. Um, Even better than that, this code we can put in an external code library, and we'll see what I mean by the code library. But it's you can import this in an external method and then call it. So I define calculate interest one time, and I never have to define it again. Okay, so that shows you creating your own code here. Now, let's see here. I got a mount here. And let me get rid of that. I'm calculating amount here. Let's not set it equal to LB amount here. Let's set it equal to right here. Well, notice it gives me a red squiggly. It won't even let me try to run it. It cannot find that symbol. When I have a method defined here, and I have variables inside, these are defined as local. These only exist while this method is running. Before this method is run, they don't exist. After the method is done, they don't exist. So when this runs this method, it takes these variables here, and the program goes to RAM and says, okay, well, it doesn't go to RAM, but it's assigned, says, okay, we're going to put this principal in this position, this memory location in RAM. We'll put this rate and time and amount in this position in RAM. Gets done running, and then it says, hey, I'm done. You can have that memory back. So it releases that memory that was allocated in the random access memory. So when I'm trying to access that mount down here, I can't do that because this is local only to this program. Now there's ways around that. That's the methods where we're returning a value, where we don't got a void. Void means nothing's returned. So this has to be back up here. Can't have that. Now, clear up here at the top, you're going to see your main public class. It's not the package, but this first line here. Don't worry too much about this, but realize that anything you declare up here is called global. Now, I'm going to be emphasizing this more and more as we go along, so if you don't understand it fully, don't stress about it. Global. This means that we can access it anywhere in this class, which means since these are all contained in that class, then I can have this right here. Now, it gets a little bit confusing when I have a mount declared up above and a mount declared here. So I'm going to get rid of this amount here. So when I'm going through, these are all local, and then this is a global variable. So I update it here, it's stored off, and then down here I can access it in a separate method. Let me show you that that works. And you see we got our answer. It is not good programming practice to use too many global variables. It doesn't lend well to code reuse because this is assuming that everybody has to have a variable declared as mount as a double. And we're going to see a lot more into objects and object-oriented programming, so we'll see how that defeats the purpose of that. In addition to that, this uses memory throughout your entire program, never releases it. Well, if your program's going to be running all day long and it's going to be using up a lot of other memory, then that's just more memory that's taken. Now, with the amount of RAM that people have anymore, 16 gigabytes of RAM and so forth, be a terabyte here pretty soon. Then you might say, what's the big deal? We got lots of random access memory. Well, you may be programming for a device that doesn't have much memory. Okay, I'm gonna get rid of that global. Sometimes I still use global, by the way, just because I can't figure any other way around it, because I'm passing it and using it so much throughout my entire program. And so it's a real pain to keep passing it and retrieving it from different methods. Okay, so let's come down here. Notice the problem here. I was sitting here. Why did I have a mount? I thought I deleted it. That's because we have the code duplicated. This is why it's not a good idea to have duplicate code, because you get confused. This would be better here if I got rid of this and just had a call calculate interest. Now you can have a method call another method. For example, maybe you want to check to make sure well, that's really hard without returning a value. But you can have one method call another one. We really won't go into that. I have a hard time thinking of an example. I mean, I think I have one in here, but it's really hard to think of a practical example that doesn't return a value. And we're taking methods slow. Okay. Now this talks about where you're going to call one method from another class. So you see that you have a new class.java here, and you got the second one .java. Everything we've seen up to now has been contained in one class, but now you can have two classes. Now here's my first one, new class.java, and got our system out, printf hello, and then we refer to the second one. Notice the name of the second class is the second one.java. So that's where the second one comes from. .test. And you notice over here, this has a test here. So this is how you can put your code in another class. If I come here, I'm going to do a new and say Java class. And I call this business. Click finish. Business.java. Now here we have our public static void test. I'm going to put my public static void, and then I'll call the calculate interest. This is really going to be hard without returning a value. Calculate interest. Okay. Now notice we're in the same package. Since we're in the same package, test pack, then we can access it. So over in my other code, if I go back to new JFrame form, and here I'm calling calculate interest, I could call business dot calculate interest. Now this is going to run the code over in the other one. So if I copy this And let me comment that out. Paste that in here. There we go. Now notice, it doesn't find TF principal, TF rate, TF time, and LB amount. This is what I was talking about. It's tricky when you put it into a separate class unless you're passing information back and forth. So that's what we're going to do. We're going to change this. Here I'm going to pass in principal. I'm going to pass in rate, and I'm going to pass in time. Okay. And I don't need those actually. And I'll calculate my amount. Amount is equal to that. We still have our problem. LB amount is not declared in this class. It's over here in UJ frame form. And you might say, what do you mean? I've never declared it. When you drop it on, if I expand that generated code there, when you create your form and you drop on those different items, it creates it for you. J label 1, J label 2, J label 3, TF principal. So it's doing all this code for you. You could write this yourself, by the way. People that do Java completely from scratch are the ones that write this. So if you want a text field, you add on a new name. You'd say like, well, it won't be edited. But if we were doing it outside this package, then I could do TF underscore addition equals new Java X dot swing dot J text field and so forth. But anyway, that's all created for us. So it's only unique to this class. You notice how it's referred to as private. So you can't access it outside of this class. So we're going to do this a little bit different. We're going to return the amount. By the way, if you're wondering why did static not work in the other one but works here, static allows you to call it from another class. So there's more to it than that, but that's where you can think of it now. So I'm going to return amount. Return amount. Like that. Now it comes back and tells us incompatible types. The reason why is because we said that this is void, meaning nothing's returned. So if I come up here and say I'm going to return a double, this is jumping ahead a little bit, but this will return a double. So to calculate amount and the return amount. So then over here in my other code, we have to program it a little bit different. Okay, so where's that at? Down here. What do I need? I need these items right here. So I declare a double principal rate time amount. I retrieve principal from my form. I retrieve rate. I retrieve time. And I want to call calculate interest and set amount equal to business calculate interest. Now, over here, I'm passing in 3 parameters. Now, the book will talk about parameters versus arguments. I just like to refer to them all the time as parameters. It's just easier. So we're going to pass in principal. We'll pass in rate, and we'll pass in time. Okay, so let me clean out some of these. I want you to see what I'm calling. Isn't the old code. Okay. I'm going to do this completely from scratch, just so you see what I want you to do in the project. Okay, now put 3 and 0.04 here and 5. And I'll click calculate. Is it calculate 2 or calculate 1? Oh, I retrieved it, but I didn't set it to the label. LB underscore, what's the label called? Amount dot set text string dot value of amount. Try number 2. 3, 0.04, and 5. And that calculates it. Okay. Let's see what else is here. Flow of execution. I'm talking about parameters and arguments, the difference between them. We already talked about passing in parameters, multiple parameters. That's really if you're doing a console, so I'm not going to worry about that. The documentation is kind of easy. I won't cover how to do documenting your methods. We'll probably cover that later on, mainly because I want to do an entire application from scratch, so you see what I want. Close project. Close all projects. Okay, so I'm going to do a file new project. Java with Maven, Java application. Physics methods. Okay, so I'm going to come here and I'm going to on my source package here, I'll right click and I'll say new and I'll choose JFrame form. This is going to be my main graphical interface. Now I'm going to put my code over here in another class. So I'm going to right click on the package here again and choose new and choose Java class. And click this will, what do I call this? Physics. If you choose business formulas, type business. If you choose physics, type physics. Chemistry, whatever you want. You can actually name it whatever you want within reason. Click finish. Okay, and here we're going to put our public static. I'm going to return a double and calculate. Let's see. Force equals mass times acceleration, so I'll calculate force. I'll go back to my standard one. I'm going to pass in mass, and I'm going to pass in acceleration. And I'm going to declare force and calculate it. So force is going to equal to mass times acceleration. And then I'm going to return force. Okay, so what I'm doing here is I'm declaring a method that I can call from anywhere. In theory, we're going to see later on, we could define this, and you could use it in multiple programs, not just this one specific to the physics methods that I created here. And that's the beauty of these external packages, or not external package, but external class, is I can bring it in and use it in multiple places. Once I program this, I never have to program it again. Public and static is so I can call it from the other class, the new jframe.java. Double is the type that's returned. If you return the integer, you put an integer there, or int. This is name you're giving it. Calculate force. These are what's going to be passed in. I'm going to pass in mass, and I'll pass in acceleration. I declare a variable called force, calculate it, and then return it. Now let me come here and Google physics formulas PDF site asterisk.edu. I'm going to put 2 more methods out here. I'm only going to call one at this point. W equals M times G. I don't know what that is, but I'll program it. Okay. So right below here, I'm going to have public, static, assume double, calculate. I'm going to say W's work. I'm guessing it is. And I'm guessing M is mass and G is gravity. So I'm going to say double mass, double gravity. Okay, so I'm going to declare double, I'm calculating work. And work is going to equal to mass times gravity. And then I'll return work. Okay, so I just got my second formula designed. Let's put a third one in there. And this looks like an interesting one. I'm guessing force F, but force C. I'll call it force C. I do not have a physics background. Public static, I'm assuming it's double. Calculate force C. I'll be passing in 3 parameters. M, which I'm assuming is mass. R, let's say it's radius. And that's not W, but we'll say it's W. And called Weta. I don't know. Double mass, double, what did I say the second one was? Radius. And double, I'll call it Weta. Do not stress that you don't know what these formulas represent. Make up names like I'm just doing. In real life, you would ask the user, okay, you want me to program this physics formula? What does this W-looking symbol stand for? And they'd look at you, roll their eyes, say that's a Greek symbol. But anyway, here we're just testing creating methods and returning. Okay, so I'm going to be returning force C. So I'm going to declare a variable force C. And force C is going to equal to mass times radius times, and I'm going to use math.pow and raise Weta to the second power. And then I'll return force C. This is what I want you to do. This is the exact project that I'm going to have you create, but you're not going to use the same 3 formulas that I'm using. You pick your own formulas. If you're not doing physics, you're doing business, do business.java. If you're doing chemistry, do chemistry.java, and so forth. If you're into math and you want to program some kind of math calculation distance, then choose math. Well, not math.java. That would really mess you up with math already being defined. But you could my math. You could give it the name of that. Okay, so we got that. Let's go back to this this application here. We're going to have 3 parts to our screen. That's going to call each one of those separately. And first one is force equals mass times acceleration. Okay, so I'm going to have a label here. That's going to be force. This will be mass. I won't make this big since you've already seen this. A button, and this is going to return force. Okay, mass and acceleration. So I'm going to name those. Right click, edit text, mass. Right click on this one, edit text, acceleration. Right click on this one, edit text, force. I won't put much effort into making this look good. Edit text, calculate, force. Okay, I need 2 text fields. And I'll label. Okay, right click on that one. I'll say change variable name. I'll call this TF underscore mass. Right click on this one, change variable name, TF underscore acceleration. Right click on this one, I'll call this change variable name, LB underscore force. Okay, and I'm gonna right click on this and I'll say change variable name. I'll call this button calculate force. I'm gonna right click on this and I'll choose events, mouse clicked. And I need to retrieve mass. Well, I need force also. Mass acceleration. Mass is going to equal to double dot parse double TF underscore mass dot get text. Acceleration is going to equal to double dot parse double TF underscore acceleration dot get text. Force is going to equal to, and I'm going to call physics dot calculate force. By the way, the Java documentation, see how this is Java doc not found? That's because we didn't create it, because I didn't want to take time to do that today. But calculate force, pass in mass and acceleration. And then I want to write that out. LB underscore force dot set text string dot value of force. Well, let's test that before we do the other two. Okay. 3, 4. 3 times 4 is 12. Okay, so that's working. Let's go back to design. That's going to be one of our formulas. So the other one is, what is this? Work. Work is equal mass times gravity. So I'm going to have one here in the middle. There we go. Text field. Where in the world's text field? I'm blind. There it is. My eyes used to be so good. As I've gotten older, they're not so good. Okay, what in the world? No memory. Work equals mass times gravity. So I need the mass and gravity. So right click on this, choose edit text, mass. Right click on this one, edit text, gravity. Right click on this one, edit text, and calculate work. This one I want to give a name. I don't want it to be a TF underscore mass. I want to choose variable name because TF underscore mass is already used. So I'll call this TF underscore mass 2 for our second one. This one, change variable name. I'll call this TF underscore gravity. Right click on the button, choose change variable name, button. What am I calculating? Calculating work. Right click on that and edit text, calculate work. Right click on this label. This is going to be my work, so I'll change variable name and I'll call it LB underscore work. I'm not doing it, but well, let me go ahead and do it. You right click, choose edit text, backspace, resize. Right click on that, edit text, backspace, resize. And did I name that one? Oh, I haven't edited text. Let's just say 0.0. Okay, so let's program this now. We're bringing in mass and gravity, so right click, choose events, mouse clicked. And I need calculate and work. I'm bringing in mass in gravity. Mass is equal to double dot parse double tf underscore mass 2, I think it was, dot get text. Gravity is equal to double dot parse double tf underscore gravity dot get text. Work is equal to, and I'm going to call the physics formula, dot, calculate work. And I named them the same, so it defaulted to that. It wouldn't. I don't think it was smart enough to fill that in for me. lb underscore work dot set text string dot value of and work. Okay, not a very exciting formula. It's basically the same as the other one, multiplying two numbers together. But let's test it. 3, 4. Click that. Okay, that's working. Now let's do our third one. Our third one is calculating for C. So we need to bring in mass, radius, and weta. Some of the other physics is just cringing at my lack of physics knowledge. I like to choose physics because it helps point out to you that you don't have to be an expert on every subject area to program. The user will provide that necessary information. You just need to know how to program. I'm not going to get that perfect. There's tools up here where you can space them, but I have. Where in the world does that go to? Maybe I will use those. There. Interesting. Okay. Yeah, if you want to play with these, you highlight whichever, or you select whichever ones. You do your rectangular select where you click with the left mouse button, hold down and drag, and then you can use these to apply the spacing. Might drive you crazy how things bounce around, like that one that kept going up there. Trying to get things perfect on this. Trust me, if you ever program one of these completely by hand, you'd be find this a blessing, no matter the flaws behind it. Okay, so what do we got? Mass, radius, and weta. So I right click on this one, say edit text, this will be mass. Right click on this one, edit text, this will be radius. Right click on this one, edit text, weta. Right click on this one, edit text, backspace, enter, resize it. Right click on it, change variable name. I'll call this tf underscore mass 3 for a third one. Right click on this one, edit text, backspace, enter. Right click, change variable name, tf underscore radius. By the way, when you have this selected over here, you can come over here and change your text over here. See how this is JText 3 or JText field 3. Do a backspace enter there. You can also change it. They provided those there because those are the most common ones when you're designing is edit text and change variable name. So I call this tf underscore weta. This will be calculating no memory for C. So right click on that, say edit text, calculate force C. Right click on that, this will be force C. Right click on that one, change variable name, I'll call it LB underscore force C. Right click on that, say edit text, I put 0.0 there. Now I'm gonna write my code. So I right click on that, choose events, mouse clicked, and I'll bring in, what am I gonna bring in? I'm calculating force C. I'm bringing in mass, I'm bringing in radius, and I'm bringing in weta. So mass is equal to double dot parse double tf underscore mass 3 dot get text. Boy, that would have been bad, because it would have referred to the mass over in the first one. Radius. Double dot parse double tf underscore radius dot get text. Weta is equal to double dot parse double tf underscore weta dot get text. Now I'm going to call force C is equal to physics dot calculate force C. That wasn't right. There we go. Mass, radius, and weta. I got them named the same. I don't think I was smart enough to fill those in. LB underscore force C dot set text and string dot value of force C. Okay, so let's run that. Make sure that's working. 3, 2, 5. This will be squared. That's 25. Times 3 is 75. Times 2 is 150. Okay, and that's working. Now that's what I want you to do for the project. I want you to pick, have two separate files over here, one for your design and one for your formulas. You pick 3 formulas, not the ones I picked, so your choice. And then you'll have 3 subsections on here. We're going to see later on how you can use some of these other features to separate those. But for now, just have 3 like this, and then of course get the code to work, and that'll be the project. Look at that, 2 minutes to spare. Well, we'll go ahead and stop there, and I apologize for this not being out on Friday. The internet was down at the, well, at least at the Wellington Center on Friday morning, which was a real pain, because usually I don't like to create these on the weekend, because sometimes my weekends are chaotic. So I meant to do this on Friday afternoon or Saturday, and it's just time got away from me, and I didn't have time until today. So I apologize for that. Hopefully we don't have internet difficulty in the future, because that puts a real damper on synchronous learning.